Let's go for the rest. This is a good place to revisit a quantity we introduced earlier. The median, okay, the middle number. So why are we discussing about median is that median is not affected by outliers, and we saw in previous example that there were lots of outliers just like these ones, right? So that's why we need to make sure that this doesn't mess up our calculation. Okay, so here you can see that if you sort the female hurricane data and pick the middle number, we have 63 data points. When sorted, they look like this. So this is the this is in ascending order, and 32nd is the middle number, which is 5. Okay, somewhere just like this. So median is 5, and for male named hurricanes, you can see that these two are the middle numbers and their average is 5. So median are the same for both of these. Now conclusion: the visual inspection of output data implies that indeed for most of the time both female and male named hurricanes behave very similarly. Okay, claim approximately 5 victims each for each hurricane. Okay, the median, since they are both equal to 5, obviously they concur. Comment: in Excel one need not actually sort the data in order to compute the median. It's enough to type median array. Okay. The above discussion is convincing. The majority of hurricanes that toll within the range of 1 to 50, and this is true regardless of the gender. Thus one should not jump into conclusions and claim that there is significant difference, and that is what t-test did. It did not jump to conclusions. Okay, so but how did t-test manage to do so? The standard deviation is the key to this answer. Okay, standard deviation is a measure for saying that variance of the entire distribution. Okay, it turns out that t-test relies on standard deviation in order to produce p-values. The mathematics behind this is a bit involved, but in a nutshell, the larger the standard deviation, the more uncertainty in data, and we get more worse p-value. Okay, so keep this thing in mind. Larger the standard deviation, there is huge variation in data, then that means there is uncertainty in the data, and thus we get worse p-value, bigger p-values. Okay, to compute standard deviation, one use the following complicated data, and we have already done these kinds of things. We have already figured out the standard deviation in Excel, so it's not a big deal. You just type stdev, and in bracket you just come up with the array, okay, or the column where you need to find the standard deviation. For the male and female hurricane data, we get enormous standard deviation, 21.16 to 34.56 respectively. They are multiple times larger than averages, strongly suggesting a large variability within the data. So there is a strong variability within the data, since 21.16 and 234.56. Those are very large. Okay. Consequently, the t-test returned a bad p-value. It's a very large p-value. The narrative makes sense. If data contains very large random variation, t-test cannot be conclusive. Thus the p-value cannot be too small. Here it says that thus the p-value won't be small. That's what it is trying to say. Interesting note: this particular example was brought to my attention from a former student statistics class with me, and later on read this rumor on the internet. Being a good student, she did not believe the rumors and bogus explanation therein. Instead, she just performed a t-test. So for the male named hurricanes and female named hurricanes, we can do these kinds of things and be aware of the bogus explanation. Okay. Important fact: it would be wrong to use a t-test and conclude that it is very likely the averages are the same. No. The only conclusion we can make is that we cannot claim that they are different. So for bigger p-values, we can say that we cannot claim they are different. And rule of thumb: if p-value is very small, then we can write phrases like very certain or very confident, but we cannot say absolute truth or absolute false. Okay? If the p-value is large, then we can only write we do not have enough evidence to conclude the averages are significantly different. So please mark this highlighted things, okay, and we'll need this again and again. Okay. Now task 3, open SAT data the setup, there seems to be a connection between SAT scores and the college GPA. Now, perform appropriate test or statistics procedure to address this assertion. Let's read this question properly. There seems to be a connection between SAT scores and their college GPA. So here it's the case of regression, okay, not t-test. Since it says there seems to be a connection between SAT scores and college GPA. It doesn't say that we are testing whether there is significant difference in their averages. It's not saying that. So that's why we go for regression. So the question was not if the average SAT scores are different from GPAs. That should be the question in order to use a t-test, okay? But the question was if there is a relationship between SAT and GPA. Thus regression is needed, okay? That is, we are testing if variable SAT is influencing variable GPA, okay? What test should we perform? Regression. What is the associated p-value? So let us go to the SAT data that we have previously come up with. Go to data, data analysis, and go for regression. Click on OK. Input Y range. Y range is college GPA, so we need to go for this one. And X range is SAT. Click on levels and click on OK. So let us see what are the p-values and everything else. Okay, so p-value is 2.41686 e to the power negative 8. So that's a very small thing. Okay, 2.416417 to the power 8. Yeah, I think I should write in this way 10 to the power negative 8. Okay, so that's our p-value. Okay, so that's it. What is the statistical interpretation? Statistical interpretation is that p-value less than 5%, we can be very certain that there is a very good relation between SAT scores and GPA. So we can be very confident that there is a relationship between SAT and GPA score. So what is the conclusion? That there is a very good relation. Okay, so that's all.